right, class, let's continue our chapter 2 with applied optimization. What does that mean? So we're going to put these minimum and maximum values we're finding to good use in application. So finally, we'll see some business applications on this, okay, not just graphic. Okay, so we often want to find what's the highest possible, right? What's the lowest possible? In other words, what could be my maximum profit, right? How much can I get out of these items I'm producing, yes, under certain conditions? How low can my costs get, right? What's the highest amount of items I can be producing, and so on and so on. So, however, though, many times a function is only defined on a certain interval, and it doesn't go all the way from negative to positive infinity, as we've seen. So let's say I have a function. Let me graph something for you. Let's say I have a function that might be producing, let's say x is number of items, right? And let's say this is profit, right? Okay, so great. And you've graphed this function, and it goes up and down and up and down and up and down. There you go, right? That's your graph. The thing is, really, truly, you cannot, you cannot produce a negative amount of items. No matter how much you try, that's not going to happen. So it doesn't even make sense to look at this graph until you start at 0, right? The other thing is you can't produce an infinite amount of items, right? There's budget constraints, right? You can only produce so much in a day. You're not going to have infinitely many workers and an infinite amount of time in a week, right? So it might not even make sense to, let me see where I'm going to cut this. Oh, I can cut it there. Here. I'm going to cut it from here on out. Just wanted something specific. So let's see, that's the most I can produce, right? With the budget I have, with the space I have, the machinery I have. So all I'm going to do is look at this graph really from 0 on up to this point here. So in this cut-out version of this function only, right? Where is there my maximum and where is there my minimum? So the other thing is, again, I don't care that there's an absolute min here or a local min, right? Or another maximum here. I'm only looking at from here to here, right? Now what I want to look at is the global maximum and minimum. So what's the highest possible value? So as I push this graph, right? That's it. That's all I'm looking at. So where is my maximum going to be? Clearly there, right? So clearly, right here is my absolute or global maximum. Remember I told you I like the word absolute better, okay? What's the lowest possible value? Okay, so I'm going to push this down, and it looks to me that the lowest possible value is going to be here. Now, if you think about your graph before, or the graphs we're looking at, or even this one, the whole thing weaved left and right, we saw that what? We saw that absolute mins and maximum pretty much occur where there's a local min and max. So which ones are local mins and maximums? These turning points, yes? This isn't a turning point, okay? So why did it become an absolute minimum? Because that's where we cut the graph, right? Otherwise, there would have been no absolute minimum, right? This would go down and down and down to negative infinity. So I wouldn't have even gotten a lowest possible value. So it just so happened because I cut the graph there, that's where my minimum was. So on a, let me write this down. On a closed interval, what does it mean, closed interval? Some value a to b, not infinities, right? Infinity is not a number, right? And it's not closed for sure, right? Infinity always gets a what we call open parentheses because you can't reach that the point infinity and stop, right? Infinity is not a number. So in a closed interval from 0 to 5, right? Including the end. So closed means including the endpoints. Okay? So on a closed interval, when you have the endpoints included, a minimum, an absolute min or max, or both, the absolute min, I should say the absolute min and max. You're going to have both. The absolute min and max occur either at a turning point. What do I mean by a turning point? A possible local min or max. Right? Or at an endpoint of the interval. The interval. So this is what I'm saying. If you want to find your absolute min and absolute max, what you need to look at, you need to look at the turning points in between. So do I need to look at this turning point here, right? No. Why don't I need to look at here? Because it's not in the interval considered. I don't care what's outside of this interval. So if I have a turning point that's outside of it, who cares? It's not an absolute min or max from here to there, right? That's what we say. So you have to look at either a turning point within the interval, I should say. I'm going to write it again. Or at an endpoint of the interval. So, right, that's where you're going to find your mins or maximum. Either here, 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 or here. So these are the only 4 points of interest. Okay. Min, max, endpoints. Now you're looking at these 4, and what are you going to do? You're going to pick which one has the highest y value. Oh, this one. Which one has the lowest y value? Oh, this one. So that's your max and that's your min, right? Absolute highest ever. Okay. So this is what we're going to do. To find an absolute max or minimum, we're going to have to go through a few things. First of all, find all critical numbers and just keep those from A to B, okay? Because you're interested in only what happens from A to B. So you're going to find your possible local mins and maximums and just look at what's between A and B. Second of all, plug in all the numbers above from step 1, right? So all your critical numbers from A to B, right? The ones that you have possible, a min or a max, right? So a turning point, okay? And A and B into the function. Okay? And then what? As I just said, your highest value is the highest value is your max. The lowest value is your absolute min. That's it. So again, one more time, what are we interested in? Where are possible turning points? Yes, from A to B. Look at A and B. Okay? And pick all those 4 numbers in this case that you found. Whichever produced the highest y is the max. Whichever produces the lowest y is your min. Okay, that's it. So Find the absolute min and max of the following function on the given interval. So here's my interval, and we want to go from 1 to 5. So what do I have to find? First of all the critical numbers. How do I find the critical numbers? I'm going to find that first derivative, set it equal to 0, or see where it might be undefined. So that's going to be a 6x minus 3x squared. Set it equal to 0, as I said. I can factor out a 3x times 2 minus x, right? So what are the two possible solutions here? Either x is 0 or x is 2. Okay, so all I'm going to do is look at whatever points are of interest. So what are my points of interest? Well, kind of say, to keep it simple, again, you're going to put what? All the critical numbers from A to B, yes, and A and B. So I'm going to put 1 and 5 and see what else might fit in between. 0 doesn't fit between 1 and 5, right? Even though it's a critical number, it's outside of where I'm supposed to look at. 2, though, fits, okay? So where do I plug these points in? As always, into the function, right? Not the derivative. That's a common mistake. Plug in a 1, so 3 minus 1 is 2. Plug in a 2. 3 times 4 is 12, minus 8 is 4. Plug in a 5. 3 times 25 is 75, minus 125, that's a negative 50. Okay, and that's an easy decision. Which one's your highest value? This one. Which one produced your lowest value? This one. So on this interval, right, this function will take its highest value at 2, and the highest value is 4. It will take its lowest value at 5, and that lowest value it takes is negative 50. That's it. Okay. All right. So let's do this a few more times. Okay. So it seems pretty easy. Find the derivative, the critical numbers. Okay, so here's my derivative. Ooh, it's a chain rule. Be careful. So it's going to be a 2 times x squared minus 1 to the power of 1 times, move into the parentheses, take the derivative of the inside, which is a 2x. Okay, so I'm going to make this a little bit better for you. So that's going to be a 4x times, by the way, the x squared minus 1 can be further factored into an x minus 1 and an x plus 1. Yes. So again, remember, the chain rule. Yes. So the derivative of the outside, right? Keep the inside the same, times, move on and take the derivative of the inside function. And then, like always, you want to multiply whatever gets, simplify it a bit, right? So numbers can be multiplied in any order. So I can multiply the 2 to the 2x at the very front, times further on the x squared minus 1. To save some time, I factored it. Why did I save some time? Because I know I have to factor to solve this equation, right? So the possible answers are 0, 1, and negative 1. Okay. So all I'm going to do is throw all that's necessary into the function itself. What is necessary? Well, this is going to go between negative 2 and 2, yes? So of these numbers, which one fits between negative 2 and 2? All of it. Okay, you don't necessarily have to put them in order, but you just need to make sure that they all fit in your interval, yes? And if it doesn't, just like the 0 before, you throw it away. Okay, so I'm going to plug all of this into the function. Negative 2 squared is 4, minus 1 is 3, squared is a 9. The same thing happens at 2. 1 or negative 1, same thing. Those are both going to be 0. And then 0 minus 1 is 1. I'm sorry, negative 1. Square that. That's going to be a 1. Okay. So which one's the highest? This one. But that's not all. This one's also the highest. So both of these are absolute maximums. So this is, by the way, a symmetrical function. So it's going to look the same one way and the other, coming up and then again. So we reached the maximum twice on this interval. Which one's your lowest? It's going to be 0, right? That's the lowest y value. So both of these are going to be our absolute mins. So I have 2 maximums and 2 minimum values. It's a symmetrical function. Okay. Now, most common mistake for students to make is to plug it back into the derivative. No, it's the function, right? Always, right? It's the function who you graphic. It's the function who you want to find minimums and maximums of, okay? So be careful about that. Okay. All right, it's getting dark in here. So let's finish this page for this video. Let's find the derivative, right? I'm absolute min and max. Again, I'm giving you some tricky functions. This one's going to be a quotient rule, right? So it's the derivative of the top times the bottom minus, keep the top alone, times the derivative of the bottom all over the bottom squared. So that's an x squared plus 1 minus 2x squared, x squared plus 1 squared, combined like terms. So that's a negative 1 x squared plus 1 over x squared plus 1 quantity squared. By the way, these don't cross out. Why? That's a negative. These are different, yes, from each other. Okay. All right, so when is this first derivative going to equal to 0? As we've seen this many times, a fraction only equals to 0 if the top is 0. So as you see, plus minus 1, yes, makes the top 0. Good. Can this derivative be undefined? Yes. If the bottom is 0. So can this x squared plus 1 ever be 0? The answer is no, because x squared can never equal to negative 1 when it comes to real numbers. So if anything, that's not possible. So the bottom is never 0, right? This is a positive. Plus 1 is always going to be a more than 1, so it's never going to be 0. Okay, so let's find our y values. What interval am I looking on? -3 to +3, yes? That says right here, yes? Okay, which ones of my critical numbers fit in here? Okay, these are my critical numbers, by the way. So which one of the critical numbers fit in there? Definitely both -1 and 1 are in between -3 and 3. Great. So let's plug them in. -3 over 10, -1 over 2, +1 over 2, and +3 over 10. So of these values, which one's the highest? In fact, 1/2 is more than 3/10. Okay, and the lowest is -1/2 is the lowest value for y. Okay, and this is it. Simple. Okay, so we practiced on all of it, finding critical numbers, plugging values in. The good news is we don't have to graph the whole function just to figure out where your min and max are. Why? Because we're cutting the function on a smaller interval, so we have the luxury to only look at what happens in between. Okay. All right, and the last one for this video. It's getting dark here. So the first derivative is going to be 3x squared minus 12x. That's it. Set it equal to 0. Factor out a 3x times x minus 4. So the two possible critical numbers are 0 and 4. Okay. What do I do with these? Well, I'm going to see which ones fit between what and what values. From 0 to 6. Okay, so 0 already matches this one. I don't have to plug it in twice. 4 definitely fits in between, so I only have to look at 3 points. Plug it all in here into the function. Plug in a 0, you'll get a 22. I have the other values. 4 cubed, that takes me a little bit longer. But plugging in a 4, I'm going to get a negative 10. And plug in a 6, I'm going to get a 22 again. Okay, so which one's the highest? Both of these. So I have 2 absolute maximums. Okay, which one's the lowest? This one here. Okay, so if I wanted to find lowest possible cost or whatever on 0, 6, it happens when I produce 4 items, right? Highest profit from 0 to 6 when I produce either 0 or 6 items. Won't make much sense, but yes, we're just practicing on random functions. Okay, so we're going to end this video here and the rest of it with a little bit more light.